One boot, 4 billion years of dust. And then, everything changed. For 3.8 billion years, the lunar surface had known only starlight, micrometeorite rain, and silence. No wind to erase a single footprint, no rain to wash away a single scar. Then, on July 20th, 1969, that silence broke. For the first time ever in the history of our species, 57 years later, most people assume that story already has an ending. A flag, a photograph, a line in a textbook. It doesn't. Here is the question almost nobody is asking out loud. Are we really going back to the moon? And if we are, what exactly will be different this time? Because the moon that Apollo 11's astronauts walked on is not the same moon scientists are studying today. New data says it is still moving, still cracking, still hiding water we cannot yet fully explain. And somewhere on Earth right now, a countdown clock is already running toward a second landing. This is the story of both countdowns, the one that already happened and the one that hasn't finished yet. On July 16, 1969, at 9:32 in the morning, a Saturn V rocket, still to this day the most powerful machine humans have ever launched, carrying Neil Armstrong, Buzz Aldrin, and Michael Collins, tore itself free of Earth's gravity. 76 hours and roughly 240,000 miles later, nearly 10 times around the Earth laid end to end, Apollo 11 slipped into lunar orbit. On July 20th, at 1:46 in the afternoon, the lunar module Eagle undocked from the command ship, carrying Armstrong and Aldrin down toward a dark, flat plain called the Sea of Tranquility, while Collins alone circled above. While Armstrong and Aldrin worked the surface, Michael Collins orbited alone above them. And from his window, he watched the Earth itself rise over the moon's gray horizon, a small, impossibly blue marble, suspended in absolute black. For that half hour, he was the loneliest human being in existence, and the one with, quite possibly, the best view anyone has ever had of home. At 4:17, with less than 30 seconds of fuel remaining, Eagle touched down. 6.5 hours after that, a single boot pressed into regolith, the fine lunar soil, ground that had waited 4.5 billion years for a visitor. That's one small step for man, Armstrong said. One giant leap for mankind. 600 million people, nearly 1/5 of every human alive at the time, watched it happen, live, in real time, on flickering black and white screens across the planet. Armstrong and Aldrin spent 2.5 hours outside Eagle, planting a flag that had to be held rigid by a wire because there was no wind to make it wave. Reading a plaque that said, "We came in peace for all mankind." Gathering rock and soil samples, setting up instruments that are, remarkably, still yielding data today. 4 days later, their capsule fell through Earth's atmosphere and splashed into the Pacific. And the 3 men who had touched another world spent the next 3 weeks in quarantine, in case the moon had sent anything back with them. But here's what the history books rarely stop to say out loud. Apollo 11 was never meant to be the end of an investigation. It was the first data point in one that is still, right now, wide open. Take the ground itself. For decades, scientists assumed the strange boulder trails near the old Apollo 17 landing site were caused by micrometeorite impacts, small rocks falling from space, nudging larger ones downhill, grain by grain. New seismic analysis says that explanation is wrong. The real cause is moonquakes, tremors radiating from a fault line, a wrinkle in the crust longer than several football fields laid end to end that has, astonishingly, stayed active for millions of years. The moon we called dead 57 years ago is still, quite literally, shaking beneath the footprints we left there. Engineers planning future Artemis habitats now have to ask a question Apollo's designers never faced. Where exactly is the ground actually stable? A fault line that has been quietly active for millions of years is not just a scientific curiosity. It is now a design constraint for anyone hoping to build something permanent up there. Listen to it this way. Imagine sonar pings from deep in the lunar crust translated into sound. A slow, low pulse, patient, ancient, still going. That pulse has been running longer than our entire species has existed as a technological civilization. Or take water, something Apollo-era scientists were almost certain the moon simply didn't have. New research, published in 2026, used temperature maps from an orbiting instrument to trace how ice has collected inside the moon's oldest, darkest craters, places sunlight has not touched in billions of years. Not from one dramatic comet strike, as many once assumed, but slowly, patiently, molecule by molecule, drifting in and freezing solid across billions of years. Scientists even discovered that the moon's tilt has drifted over time, meaning craters frozen in permanent shadow today were not always shadowed at all. The map of lunar water has been quietly rewriting itself for eons, and we have only just learned how to read it, with a new radar instrument now being built specifically to listen for buried ice we have never directly detected before. The water story runs just as deep. An orbiter called the Lunar Reconnaissance Orbiter has spent over a decade mapping the temperature of every crater near the moon's poles, 1 degree at a time. Combine that heat map with computer models of how the moon's tilt has drifted, and a picture emerges. Shadows that are ancient but not eternal, shifting slowly enough that ice could freeze in one crater for 1 billion years, then, eons later, find itself exposed to sunlight for the first time. Which raises an uncomfortable, thrilling possibility. Some of the water ice we are now racing to reach for future astronauts may be older than most of the craters sitting on top of it. Then, in 2026, 4 astronauts, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, flew around the moon on Artemis II, Artemis, the first humans to do so in over 50 years. What they saw surprised even NASA. Colorful patches on the surface, hinting at mineral deposits no one had mapped in such detail. Strange winding features the crew nicknamed squiggles. Craters that looked, in the crew's own words, almost dusted with snow, standing out starkly against the gray. During a rare solar eclipse seen from lunar orbit, the crew even watched bright flashes, meteoroids striking the surface in real time, 400,000 kilometers from home, and identified 2 entirely new craters no one had ever cataloged. 57 years after the first footprint, the moon is still surprising the very people who study it most closely. Meanwhile, back in Earth orbit and beyond, Artemis II's 4 astronauts trained for years for a mission that, in the end, lasted barely 10 days. A single loop around the moon and home again. And yet, in that short window, they returned with more raw visual data on lunar surface anomalies than some entire decades of the Apollo era combined. 57 years apart, and the moon still had new things to show the astronauts looking at it. Scientists have even grown chickpeas in simulated lunar soil, a small, almost quiet experiment that hints at something enormous, a future where the moon isn't just visited, but lived on. Which brings us to the second countdown, the one aimed at right now. NASA calls it Artemis, and its plan has changed more than once already. Artemis III, once billed as the crewed landing, was quietly reclassified, now a demonstration mission, testing rendezvous and docking in Earth orbit, currently planned for late 2027. The actual crewed landing has been pushed to Artemis IV, targeted for early 2028. And the lander, meant to carry astronauts down to the surface, SpaceX's Starship human landing system, taller than the Saturn V that launched Apollo 11, is still, as of this year, working through serious technical hurdles. Ship-to-ship propellant transfer in orbit, refueling one spaceship from another, hundreds of kilometers above Earth, something never before attempted at this scale, has not yet been fully demonstrated. Blue Origin's Blue Moon lander is being developed in parallel, almost as an insurance policy, in case Starship isn't ready in time.